The James Webb Telescope discovered something terrifying in deep space. It's time for people to know the truth. I work for NASA as an astronomer, and there are certain things we keep hidden from the public. No, the Earth isn't flat, and aliens don't control the government. Fuck, I wish those were the case, as the truth is much, much worse. In 1993, the Hubble Space Telescope saw a star disappear. It didn't go supernova or die naturally. It simply went dark over the span of a few minutes. This star was already too faint to see with the naked eye, and ground-based telescopes had trouble picking it out from among the surrounding stars, so the event wasn't widely known to the public. At the time, we thought the most likely explanation was that a cloud of interstellar dust had drifted between Earth and the star, occluding it from view. It was noted and mostly forgotten about. In 2007, 2 more stars vanished. Due to the circumstances of this event, this was much more concerning. The 2 stars in question were part of a binary system, orbiting each other at a fairly close distance. If a cloud of interstellar dust was the culprit again, they would have both seemed to disappear simultaneously or very close to it. Instead, both stars faded individually over a period of minutes, separated by a span of about 8 hours. This binary system was also about 15 light-years closer to Earth than the star that had previously disappeared in 1993. After carefully reviewing millions of Hubble images, 2 more stars were identified which had gone out in the years 1995 and 2002. These were all in the same stellar neighborhood, only a handful of light-years from each other. The only conclusion we could draw was that some unknown influence, traveling close to the speed of light, was shrouding or destroying these stars. Unfortunately, the Hubble wasn't sensitive enough to tell us any more than that. The James Webb Space Telescope first came online a few months ago. Although official channels will tell you that it's still undergoing testing, we have been actively collecting data since early February. One of the first things we did was to aim the telescope at the regions of space occupied by the vanished stars. If they were being blocked by dust clouds, a hope some of us still held onto, the increased sensitivity of the JWST may have been able to see through them and confirm that the stars were still there. Unfortunately, we had no such luck. The first 3 stars that had disappeared were still completely dark. Gravitational wave detectors, though, soon found something odd. In all cases, not only were the stellar masses still present, but the amount of mass had actually increased. More sensitive observations had also detected a type of string, or web, stretching through space connecting these now invisible stars. When we trained the telescope on the binary system that had vanished in 2007, which was the nearest point at which this phenomenon had so far been observed, there was finally enough ambient EM spectrum radiation left to try a mass spectrometer reading. If you're not aware, mass spectrometry is an incredibly useful process, whereby measuring the patterns of light wavelengths emitted or reflected by an object, we can learn tons of useful information, such as its temperature, speed and direction of movement, and chemical composition. The readings we got from the binary stars didn't make any sense though. First of all, they were cold, almost as cold as the surrounding interstellar medium. Whatever had happened to these stars had snuffed them out completely or somehow prevented their light from escaping. What was truly puzzling, however, were the emission lines returned by the mass spectrometer. Several familiar elements, such as hydrogen, carbon, nitrogen, oxygen, and magnesium were identified, but these were few and far between. Most of the readings didn't correspond to any known chemical elements, and even seemed to defy what we knew about the physics of light, matter, and chemistry. This massive, star-spanning structure was primarily composed of materials that we didn't even have names for, and may not even have been matter as we understand it. Speculation ran rampant. Obviously, such a thing couldn't be a natural phenomenon. Finally, we had proof of extraterrestrial life. But what was this thing we had discovered, and for what purpose was it being built? The leading hypothesis was that we were looking at a series of Dyson shells, massive solar collectors built to completely envelop stars in order to capture 100% of their energy output. Such a concept had been envisioned in the early 20th century as a potential source of energy for an interstellar civilization. Ever since then, the idea had found its way into popular science fiction. The construction of these massive structures had actually been theorized to be one of the first signs of intelligent extraterrestrial life that we may someday detect. It seemed that day was today. The theory still didn't explain everything though. First of all, there was the impossible speed with which the stars were covered. Constructing a Dyson shell from scratch in a matter of minutes was beyond even the wildest speculations of scientists and sci-fi writers. Then there were the mysterious filaments that connected the shells over distances of light years. No one had any idea what purpose these could serve, or how they could even be built. Everyone at NASA was fascinated by this mystery. In hindsight, we may have been better off if we had never discovered the truth. Less than a month ago, the JWST detected a series of unusual energy bursts emanating from interstellar space. These were occurring at the very edge of a star system approximately 12 light-years from the binary system that vanished in 2007. As we focused the telescope on this system, we soon determined that these were not natural phenomena either. The energy signatures, which were still flashing intermittently, matched what would be expected from thermonuclear and antimatter-based explosions, along with several other types of energies that we couldn't identify. These explosions, although still not visible to the naked eye on Earth from that distance, were absolutely tremendous in magnitude, easily billions of times more powerful than any nuke that humanity could conceivably build. After experimenting with the telescope settings, we were able to get a clearer picture of what was going on. The tip of one of the interstellar filaments that linked the Dyson system was passing through the Oort cloud of the distant star system, approaching its sun. And whoever lived there was fighting back. Their weapons were able to slow the thing's advance, shattering, breaking off, and vaporizing planet-sized chunks of the object, but it seemed to be rebuilding itself almost as fast as it was being destroyed. After less than a week, the explosion stopped. It seems that they had run out of ammunition. In the void between stars, we knew that these things traveled at nearly the speed of light, but as we watched it approach the inner star system, its pace slowed as it swelled in size, preparing to devour the system's star. We quickly trained the telescope's mirrors on the doomed sun. We were about to watch whatever this thing was blot out another star, but in real time. We all held our breath as we watched the projected image of the main sequence star, slightly larger than our own sun. At first, nothing seemed to be happening, but soon a small shadow appeared on the edge of the luminous orb, soon followed by another shadow, and then a third. The shadows began to converge, forming a strange, yet somehow familiar pattern as they blocked out the star's light. "What are those?" One of my colleagues gasped. "They almost look like..." She paused, as if afraid to say the next word for fear of ridicule. I, however, had no such hesitancy. "Leaves," I said, my voice monotone. The situation was far too incredible to express any emotional reaction, even that of pure shock. "They look like leaves." We watched as, over a period of minutes, a web of shadowy outlines, matching the familiar shapes of oblong leaves and thin vines, proceeded to blot out the remaining light from the distant star. By that point, everyone in the room had realized the truth. The phenomenon we had been tracking for so many years wasn't some hyper-advanced alien megastructure. Hydrogen, carbon, nitrogen, oxygen, and magnesium, some of the few familiar elements we had detected, they were all components of chlorophyll. It was a plant, an enormous plant that spanned across light years. And, much like terrestrial plants, it sought out light to fuel itself. The filaments connecting the stars across interstellar space were stems, branches. It would grow in the direction of the nearest stars it sensed, completely enveloping them and then moving on. Any life inhabiting planets orbiting those stars would be left to freeze to death. Or perhaps even worse, it was possible that the plant would devour those planets to add to its mass as well. Everyone was silent as the telescope continued to gather data. Eventually, after what seemed like an eternity, a young astronomer spoke up from the far end of the room, addressing our supervisor. "Sir, we've begun to detect the formation of another tendril, leaving the system. Its vector is..." He gulped. He didn't need to say any more, but he did anyway. "It's heading directly for our sun. How much time do we have?" The supervisor replied grimly. "Judging by the time lag, distance, relativistic properties, and previously observed speeds of this thing, I'd estimate no more than 27 years, sir." 27 years. We had just watched this galactic weed overwhelm a civilization that was at the very least thousands of years ahead of us technologically, and we had less than 3 decades. I'll probably be found in silence for posting this. But I don't care. I have to tell someone. I can't keep this a secret any longer. When the sun turns black and the world begins to freeze, at least you'll have some idea of what's going on. Small comfort it may be.